This is class 12, chapter 2, inverse trigonometric functions. Before learning inverse trigonometric function, we should know about trigonometric function, the basic concept of trigonometric functions. So what is this trigonometric function which you have learned in your junior classes, that is class 11, class 10 and all. That is trigonometric functions like sine theta, cos theta, tan theta, cot theta, cosec theta, sec theta. Trigonometric functions which you have learned in your class 11 as well as in class 10, right? Okay, then simple reciprocals, that is which trigonometric function is related to the other one. Okay, so which all are related to each other, we'll see. Okay, if I say sine theta reciprocal of cosec theta, that is 1 by cosec theta. Cos theta reciprocal of sec theta, that is 1 by sec theta. Tan theta, it is reciprocal of 1 by, that is reciprocal of cot theta, we can say 1 by cot theta. Next, cosec theta is reciprocal of sine theta. So cosec theta equal to 1 by sine theta. Sec is reciprocal of cos. That we can understand. Vice versa is also happening. Okay. So sec theta is equal to 1 by cos theta. Cot theta equal to 1 by tan theta. One more is there, that is tan in terms of sine and cos. That is tan theta equal to sine theta by cos theta. Same thing applies for cot theta, that is cot in terms of sine and cos is cos theta by sine theta. Nothing, again it's reciprocal of what we have for tan, that is sine by cos. Here cot is cos by sine. I hope this was the basic things which you have learned in your junior classes, right? Now, last year, that is in your class 11, you have learned how to convert degree to radian and vice versa. That is radian to degree. Okay, the angles. Okay. When it is 0 degree, you can see it is 0 radian. When it is 30 degree, pi by 6. When it is 30, it is pi by 6 radian. Okay. Next, radian you can show by the small letter c. But usually if you don't write, no issues. Okay, 45 degree, pi by 4. See, 45, 4. So pi by 4. So as you not forget, when it is 45 degree in radian, in terms of radian, what it is, pi by 4. When it's 60 degree, it is pi by 3. See, just see. 30 degree, pi by 6. When it is 36, when it is 60 degree, it is pi by 3. Just remember, okay? Uh, Next, when it is 90 degree, pi by 2. Next, 180, it is pi. 270 degree, 3 pi by 2. And 360 degree, it is 2 pi. This is all we have learned. A simple example how this degree is converted into radian, nothing. If you have a degree measure, that is supposed to convert into radian. So how do you do it? That is pi by 180 into degree measure. So when we solve it, 25 in 5 table, it is 5 times, and 180 in 5 table, it is 36 times. So 5 into pi is 5 pi by 36 really. So this is our answer. That is how 25 degrees converted to radian. Okay. You all are aware, but still a simple example I have given. Okay. I hope this is clear to everyone. Right? Moving on to next slide. Okay, domain and range. Domain. Domain means domain. If we have two sets, for example, this is our set A and this is our set B. Okay, you have element 1, 2, 3, and here I have A, B, C, and D. Okay. Now just see how's the relation. I'm just making some relations, okay? 1 to A, 2 to B, and 3 to D. Now, domain and range, this we have learned in our earlier chapter, that is relations and function, and last year have learned, even in class 11 also it was there. So can you tell me what is a domain here? If you will include one more number, can you tell me what is a domain here? In our first set, that is set A, which all numbers are having image to the other set. That is, the image is there where 1, 2, 3. So this is our domain. Which all is our domain? Our domain is 1, 2, and 3. This is our domain. Okay, 4 is not included. Why? 4 is not having an image. Next, what is a codomain? Codomain is nothing, all the elements of set P. Can anyone tell me what is the range? Which all elements from A to B is having arrow? A is having from set A to B, then B is having, then D. This is a range. That is, which all are having images. Okay, so A is 1 is having A, 2 is having B, and 3 is having D. Or you can say which all elements in B is having pre-images. Okay, that is A, B, and D. So this is our range. That is A, B, D is our range. C is left out. Is it clear? Okay. So domain, range, and codomain is clear to everyone. So we'll go for it. So we'll now here we will be checking this. We have learned last year, but still I'm revising it. Sine. So what is the domain of sine? R. What do you mean by R? Real number. And what is a range? That is your range is between -1 and 1. Why it is said so? That is whichever elements you take in your first set, this set, whichever elements you take, what will happen? The image which is formed from A to B, that is first set to second set, is between 1 and -1. So we'll see 0, that is for sine x. If your y is sine x and my x is 0, so what will happen to sine 0? 0. Sine now my value of angle is 30 degree. That is sine 30. What is sine 30? Half. Getting it? Getting it? What is sine 90? If my value of x is 90, then what is sine 90? Sine 90 it is 1. No doubt. What is sine 180? It goes to -1. What is sine 270? If you take 270, again it goes to 0. So did you notice the values is between -1 and 1? So only there we are having the images. That is between 1 and -1. Only those values are having pre-images from your first set. Is it clear? But here all the values are having image. In your first set, all the values are having image. Getting it? Okay. So that means you can take any value, you'll get an image. So any value means real number. So domain is real number and your range is between -1 and 1. Same way it applies for cos. That is your value. You can take any value for x, that is any real values, and your range will be between -1 and 1. Tan. See, R minus. What do you mean by this R minus this thing? It is nothing. We know that at tan pi by 2. What is tan pi by 2? That is tan 90. Tan 90 is undefined, infinity. Got it? So only the odd multiple of what pi by 2 of tan is infinity. That is, if we say tan pi by 2, infinity. Tan, if you take value 1, what will happen? 2 ones are 2 plus 1, that is 3 pi by 2. Again, 3 tan 3 pi by 2 is infinity. So that is excluded. Excluding that, what is the range? What is the range for tan? All real numbers. So likewise, it is followed for cot, sec, and cosec also. In the case of cosec, our domain is what? R minus, what is it is? X equal to n pi. That is multiples of pi. 1 pi, 2 pi, 3 pi. That is what it is undefined. That is 0. Cot 0 is undefined. Is it clear? So only those values are excluded. Other than that, all comes under domain from the real values. Okay. So and it is having images to all real values. So that is our range. Okay, I think this is enough. We'll go for next slide. Okay, now this is trigonometric ratio table. That is values for each angle. Sine 0, 0, half, 1 by root 2, root 3 by 2, 1, 0, negative 1, 0. I hope this all remember it. The reason is this all is taken in class 11. Got it? And cos 0 is nothing. From here, if we take its ulta, see 1, root 3 by 2, 1 by root 2, half, 0. Just make a note. And this case is also ulta, okay? From 2 pi to, okay. Is it clear? But here in this case, ulta is from where here? 0, negative 1, 0, 1. Is it clear? So tan theta, that is tan 0, 0, tan pi by 6 is 1 by root 3, tan pi by 4, 1, tan pi by 3 is root 3, tan pi by 2 is infinity, tan pi is 0 again, tan 3 pi by 2 is infinity, then tan 2 pi is 0. Okay, so I guess this all you can go through just once. Okay, so now we'll move on to inverse trigonometric function. Inverse. When we say if this is a function, inverse of f is f inverse, right? When we say a function is having an inverse, when that function is 1, 1 and onto. 1, 1 and onto. What is the meaning of 1, 1 and onto? 1, 1 means all the elements in a set A is having image. All. Okay. Same way, when all the elements in our set B is having pre-image, single, 1, 1, only single image. Okay. When in such a way it is there, it is 1, 1 as well as onto. We have learned, right? When 1, 1 and onto is there, that type of function, what do we call? Bijective function, right? Okay. So, if it is f, your function is f, and its inverse will be f inverse. So before, like, let us just go on. I have a small briefing about a function and inverse of a function. F such that a to b such that f of x equal to y is 1, 1 and onto. Okay. Then g, another function, g, c, a and b swapped. Okay. B to a such that g of y equal to x, where x belongs to x, and y equal to f of x, where y belongs to capital Y. Here, domain of G is equal to range of f. Here, domain of G is equal to range of f. Like 1 to 1, 1, 1, single arrow is from set A to set B. Same way, vice versa also it is like that. From B to A also, single arrow is there to single element. So same way, range of G, that is in this case, range of G is equal to domain of f. Okay, so then function G is called inverse of f and it is denoted by f inverse. Hence, G is 1, 1 and onto, and inverse of G is f. Inverse of G is f. Is it clear? G equal to f inverse. So what they're trying to tell is, if your sine theta is a 1, 1 and onto, that is a 1, 1 and onto function, then what will happen? Its inverse will exist. Okay. If sine theta equal to x, if sine goes to the other side, what will happen? Theta equal to sine inverse x. Is it clear? That is, inverse of sine is an angle. Inverse of sine is an angle. Is it clear? Usually when we say sine theta, we take values of angle. Right? That is sine pi by 6 equal to half. So what is a pi by 6? Measure of an angle, right? Okay. So inverse of sine is nothing, it is an angle. Okay. For example, if I say sine inverse, which angle will take sine inverse? Will take, not angle, will, what value will take for x? Half. So what is sine inverse? Not half, I'll take root 3 by 2. What is sine inverse root 3 by 2? It should be some angle, right? What angle will take? Like what answer will be the result I'm asking? It will be pi by 3. That is, you know, sine 60 is root 3 by 2. Sine 60 is root 3 by 2. Simple way will write, okay? Sine pi by 2 equal to, what it is? Equal to 1. Fine. So, how it will be? Pi by 2 equal to sine inverse of 1. Got it? So, the answer for sine inverse 1 is nothing, pi by 2. Usually in this chapter, for 1 and 2 marks questions may come or 4 mark questions may come. Is it clear? Did you understand? Either 1 or 2, 1 and 2 mark questions may come, or a single question of 4 mark may come. So this type of questions may come for 1 mark and all. Okay. So if we say theta equal to sine inverse x we have, and sine inverse half. If it is sine inverse half, what is the measure of the angle? What is the measure of the theta? Value for theta. When it is, when you just remember when is sine half? A value of sine is half at which angle? Yes, at sine 30. In radian, what it is? 30 is pi by 6. So theta equal to pi by 6. Angles always written and measured in radians. That you should remember. So, like earlier when in class 10 and all used to write in degree, right? But in class 11 as well as in class 12, you're supposed to write in radians. Okay, other inverse trigonometric functions, that is cos inverse x, tan inverse x, then cot inverse. If I say cot inverse, cot inverse, what we can take? I'll take root 3. If you don't know directly what is cot inverse root 3, I'll do one thing. We'll write uh, tan inverse. We know that reciprocal of tan is cot, or vice versa. Reciprocal of cot is tan. So what is there? Root 3, right? So I'll write 1 by root 3. So when is tan inverse 1 by root 3? At which angle is tan 1 by root 3? At pi by 6. That is tan 30. Fine. Okay. As we have learned the domain and range for our trigonometric functions, so same way we have domain and range for inverse trigonometric function. Okay, so here we have domain. See, everything is ulta in that. Okay, we'll see how it is. But this you'll understand more with graph. Okay, hold on, we'll just solve it. Okay, if this is x, sine inverse x. Will we take what values for x? Will we take angle or some values? Yes, values will be taking. What value will take? We'll take value for x as -1. So what is sine inverse -1? What is sine inverse -1? Sine inverse negative 1 is nothing, negative sine inverse x. So negative sine inverse 1. So when is sine inverse 1? When is sine inverse 1? Pi by 2. That is, so the answer is negative pi by 2. Clear? Okay, next we'll take 1. Okay, so we are taking 1. Sine inverse 1. When is sine inverse 1? When is sine 1 at pi by 2? Is it clear? Is it clear? Okay. Now in between we can take value. We'll take 0. So sine inverse 0. When is sine inverse 0? At 0. Is it clear? Now whatever value you'll take, it will be only between negative 1 and 1. Is it clear? And when you take the inverse of that value, it will be between negative pi by 2 and pi by 2. So your domain is negative 1, 1, and your range is minus pi by 2 to pi by 2. Is it clear? Same. Usually we only take sine. Why? Like, it's quite easy for you all to understand also. Is it clear? This domain range and all. Even in the previous case also I took sine, right? To show you the domain range. Here also in sine inverse also, we show you the sine y. The sine inverse, the reason is it's quite easy to understand also the domain and range. So let us move on to next slide. This is a graph, okay? How the graph is plotted. See, when the value of theta is 0, what is sine 0? 0. So we plot it here. Is it clear? Then sine pi by 6, that is sine 30. So we know this is x-axis and this is y-axis. Y-axis, what is there? This one, sine theta. We'll be plotting, and this is a y-coordinate and this is a x-coordinate. So what we have, pi by 6 comma half. So pi by 6 is somewhere here and half, so somewhere here. So no doubt. So we'll go for pi by 2. What is pi by 2? Pi by 2 comma 1. So if this is pi by 2, where is 1? Here. Next we go for pi. That is pi comma 0. So where we'll be plotting in x-axis. See here. Next we'll go for 3 pi by 2 comma negative 1. So 3 pi by 2 is here, and where is negative 1? Down. Y is negative 1, right? So this is plotted. See how it is going. Did you all understand? In a waveform it goes. So same way when we take negative also, it will go like this. Okay, is it clear? Fine. Okay. Now next for sine inverse, when we check. Sine inverse. So this is our sine inverse. What is it? Ulta of sine, right? Did you notice ulta of sine? See, what is the domain? Negative 1, 1. And what is the range? Minus pi by 2, pi by 2. So similarly, when we plot, let us see how to plot, okay? We'll see the previous slide. We have negative 1 and our y is negative pi by 2. Let's see. Negative 1 at what? X-axis. Okay. And negative pi by 2. See, plotted. Then we had 0, comma 0. See, 0, comma 0. Then we had 1 and pi by 2. Let's see. 1 in x-axis and then pi by 2. See, plotted. Is it clear? So just like what, it's completely ulta, like just tilted. The graph is tilted for sine inverse. Is it clear? And here it is nothing, like both we have our sine graph. This is our sine x and this is our sine inverse x. So one slope is plotted, that is y equal to x, and that shows that like it is a mirror image. Did you notice it's a mirror image? See, mirror image. This one's mirror image is this side. Is it clear? Okay. Similarly, it is there for the graph for cos. And this is for cos inverse. Next we have for tan x. And this is your tan inverse. It just they have tilted it. Just see. cot x and cot inverse. And this is cosec x, cosec inverse, sec x and sec inverse graph.